Okay, continuing with lesson 1.3. This is the second video, B as in boy, and we are on page 46, bottom of the page, slope of a line. Alright, I'm not going to worry about reading the story about Tokyo and all of that, but anyway, the slope of a line is basically just the slant or the steepness of a line. Now I end up drawing these little homemade XY axes, but you look at this, and the slope of that obviously is steeper than that slope. And you can also have slopes this way. Okay, and just a couple of the things, and I probably get myself ahead of myself, or ahead a little bit, but notice the blue lines all go from left to right, they go uphill. Okay, when you go uphill, it is a positive slope, and the red ones go downhill, so when you go downhill, you've got a negative slope. Okay, so for most of you, this should be review, so I don't mean to bore you with same old, but I do want to make sure that you are all on the same page and are at the same place. So first thing we need to do is we need to get a definition of slope, and remember that the symbol for slope is the letter M. I have no idea why they use the letter M for slope, but they do. So the slope is the vertical change over the horizontal change, okay, or the rise over the run, or y over x. That is the slope. So let's get a graph on here and explain that a little bit better. Okay, so I'm in the middle of page number 47, talking about the slope of a line. And what we have here, remember I just wrote this down, vertical over horizontal or rise over run. Sometimes you will see slope written this way. And that little triangle is the Greek letter delta. And you'll see that in chemistry and physics and in math, and it means change. The change in y over the change in x, which is exactly what that says right there. So let's look and see what that means here on this graph. All right, so we're using a bunch of letters here, and sometimes that can get confusing. So maybe let's do this. Let's put some numbers here. Let's say that this is 2, and this is 4, and this is 2. Let's make this 3, and this 5. Okay, which means that this point right there is going to be 2, 3, and this point right here is going to be 4, 5. Alright, so if we're trying to determine the slope, what does it say? It says we take the change in y, the difference in y. So we take one of the y's minus the other y, and we take the one of the x's minus the other x, and we get 2 over 2, or a slope of 1 over 1. Alright, and that's exactly what they did here. Okay, so instead of using numbers, they used x subscript 1, y subscript 1 for one point, and this is the other point. So what they did is they took this y here and subtracted this y. Okay, y2 minus y1 over x2 minus x1. And the difference is this height right here, which is the rise, y2 minus y1, over this length right here, which is the run. It's not the total distance from the origin clear over here. It is the difference between these 2 points. Okay, so between 2 and 4, the difference is 2. Difference between 3 and 5 is 2. Okay, so that's where they get that. Now, a key thing here. Notice y2 minus y1 over x2 minus x1. It does not matter which numbers you use. Okay, for example, let's say that I switch these around, and instead of taking 5 minus 3 and 4 minus 2, I take 3 minus 5, the other y, and put it first, over 2 minus 4. What do I get? 3 minus 5 is negative 2. 2 minus 4 is negative 2. Two negatives give me a positive. 2 over 2 is 1. I get the same slope regardless of whether I take this y minus this y or this y minus this y. So don't worry about which one do I subtract from which. It doesn't matter as long as you take the 5 minus the 3 over the 4 minus the 2. Okay, so if this point, the 5 is here, then the 4 has to be here. Okay, they both have to be first. If you use this one instead, the 3 is first, which means the 2 has to be first there. That's the only thing that's really, really important. Other than that, it doesn't matter which one of these is the y2 and which one is the y1 and the x2 and the x1, as long as you're consistent. Okay, don't want to go on and on about that, but just wanted to make sure you're able to follow what's going on. All right, so if for some reason, which probably will happen, if this number here, when you subtract, gives you a 0, you can never have a 0 in the denominator. So let's say you take the difference of y's and you get 5, you take the difference of x's and you get 0. If that's the case, it's undefined, or you draw that symbol there, which is the symbol for, ooh, that's supposed to be an N, for the null set, which means it's undefined. There is no number that exists. The answer is not 0, because 0 is a quantity. Undefined means it's not even worth mentioning. So if you get x as a 0, you've got undefined there. Okay, so I'm on example 4a. Find the slope of a line passing through the points negative 3, 2, and 5, negative 4. Okay, so really all you're doing is y2 minus y1 over x2 minus x1, or like I had mentioned before, change in y over the change in x. So y2 minus y1. Okay, so 2 minus a negative 4, so the difference between the two y's, and the difference between the x's. And we get 2 plus 4 is 6, negative 3 minus 5 is negative 8. Reduce that to 3/4, and it's negative because one negative there. So you get a slope of negative 3/4. And then it says, what does the slope mean? Well, pretty much the only thing the slope means is that it, as far as I'm concerned, is that it goes downhill. It's negative, which means the rise is 3, so you go down 3 and you go over 4. Okay. So there's something I want to mention here that's really important, is there is a negative sign here, but is that negative on the 3 or the 4? Is it negative 3 over 4, or is it 3 over negative 4? It doesn't matter, okay? So let's say, for example, we have a point, we have our line, or we're trying to draw our line, and we have a point here. It says 3, we go down 3, 1, 2, 3, and then we go to the right 4, 1, 2, 3, 4, and there's a point there. And we draw our line. Okay, that's if we have negative 3 over 4. Now let's say that we have 3, negative 4. So let's take this point right there. Let's take this point right here, and it says that we go up 3 because y is 3. So we go up 1, 2, 3, and then it says we go over left negative 4 because it's negative 1, 2, 3, 4, and we end up there. So we went this way for this one, and we went this way for this one. But the key thing is we ended up with points on the line, and that's all we care about. Okay, I'm going to let you do the B portion of that on your own. Let me know if you have any questions on that. Bottom of page 48, the relation between orientation of a line and its slope. Okay. I mentioned this earlier, and let's go into this just real quickly. If the slope is greater than 0, we go uphill. Okay, it's a positive slope. If the slope goes downhill from left to right, the slope is a negative number. Okay, if the slope is a horizontal line, there is no slope. The slope is 0. You know, if you're skiing, you're not going to go anywhere. Slope is 0. Ain't got no slope. Okay, here slope is undefined. Okay, it is not a function because every point on here, if you did the vertical line test, you would go through every point on this line. So that is undefined. Okay, instant death at Alyeska if you go down a slope that is undefined. Okay, it's called a cliff. All right, so that is the relation between orientation of a line and its slope. Okay, slope and y-intercept of a line, page number 49. How many of you recognize that equation? Raise your hand, please. Okay, I see those hands. Some of you are not raising your hand. All right, okay, I know I'm an idiot. Let's keep going here. Y equals 3x plus 2. All right, so there's an equation that's written in this format. This is called the slope-intercept form. Slope, m, and b represents the y-intercept, where it crosses the y-axis. Okay, so you can graph any line if, first of all, you put it in this format. See, this is already in that format. And all I need to know is, what is the slope? The slope is going to be that, 3 over 1. Every slope can be written as a fraction, because remember, the slope is y over x, so you need to write it in a fraction, even if it's just 3 over 1. The y-intercept, then, is this number. So if I'm graphing that equation, I don't have to use the whole plug a number in here, plug a number in here, and keep going until I can draw a line. All I have to do is, first of all, look at that. Y-intercept is 2. Okay, there's 2. That's where it crosses. And then I do the whole slope thing. Okay, so how does that work? Let me get some more points on here. Okay, so we start here at our y-intercept, and it says we go down, or we do our y value, which is 3. So this is a positive 3. So I need to go up 3 and over 1. Up 1, 2, 3, over 1. Okay, and that gives me 1, 2, 3 over 1. That gives me that point right there. If I keep going, it'll continue to go up. And what I end up doing then is drawing a straight line, connecting all my dots, and I am going uphill, and it's a positive slope, which this is a positive 3, so I know that that's true. I usually like to encourage you to draw 3 points, because if you just draw 2, anytime you draw a line between 2 points, obviously you get a line. But it's not always the case if there's 3 points. Let's say that you graphed this point, and the next point you graphed over here. Now, if you would not have drawn that third point here, you wouldn't have seen that there was a mistake here somewhere. Is the line this way, or is it the blue line? If I would have done it correctly, all 3 of my points would have been on the same line, and then I could say, oh, I drew it right because all my points connect in a straight line. And if I get something clear out here and goofy, I know that when I connect these, I'm not getting a straight line, so I've got some mistake there. So that's why I encourage you to do 3 points, because it keeps you from just assuming that you're right, because you're going to get a straight line whenever you put 2 points down. But that third point is kind of your check to make sure that you're doing everything correct.